Advanced Math ladies, this is lesson 1.4 part 3. Unfortunately, I didn't get to finish number 64, so if you'll go back to 64 from part 2, we left off with x equals 4 plus or minus the square root of negative 4 squared minus 4 times 3 times negative 2 all over 2 times 3. If you simplify what's under the radical, you have the square root of 16 plus, because minus times a minus is a positive, 24 over 6. So that gives us 4 plus or minus the square root of 40 over 6. And if you do the factoring on 40, that's 2 times 20, which is 2 times 10, which is 2 times 5. For every 2, we're going to take out 1. So that would be 4 plus or minus 2 times the square root of 10 all over 6. And as we discussed earlier in the lesson, if the 4, the 2, and the 6 will all reduce by the same thing, we need to reduce. So let's take a 2 out of the top. So we'd have 2 times 2 plus or minus the square root of 10 all over 6. Well, the 2 over 6 will reduce to 1/3, so then our final answer is 2 plus or minus the square root of 10 all over 3. The final portion of this lesson has to do with the discriminant. And we worked with the discriminant last semester, but we're going to review it again. The discriminant is the part of the quadratic formula that is under the square root. So that means the discriminant is b squared minus 4ac. The value of that can tell us a lot of things. If that number is positive and a perfect square, like 9, 16, 25, that's what we mean by perfect square, then you will have 2 rational solutions or roots, whichever way you want to say it. If that number is positive but not a perfect square, then you will have 2 irrational, meaning they have a square root that you can't do anything with, roots. Then, if it is exactly equal to 0, then that means you have 1 rational solution or 1 rational root. But something else that I need to call to your remembrance is that this will be a double root, meaning that you have the same root twice, but there's 1 unique root. And the other case is if the discriminant is negative. If the discriminant is negative, you will have 2 complex roots or solutions. On number 66, that is one of the problems in your homework, but I thought it would be best to discuss this with you. I think you would know the answer, but I think it might be so obvious that you would think you were incorrect. So, never mind. Let's just look at it. The 66 says to explain why the following equations, meaning these 2 equations, have the same solution set, which would mean answers. It also says to not solve. They have the same solution because they are the same equation, except one of them has been multiplied by a -1. because the first one is -2, +2, +3, -3, -6, +6, and so on down the line. There are two other little interruptions in this homework that I need to look at with you. One of them is 68, because you never liked factoring cubes, and so I thought we should probably talk about this one. On 68, which yours will be 69, it says solve each cubic equation using factoring and the quadratic formula. This is a cube, this is a cube. So if you remember the formula, it is a cubed minus b cubed will factor into a minus b times a squared plus ab plus b squared. If you've completely forgotten it, those formulas are still in your composition book. So in our case, a would be x, b would be 3. So this would factor into x minus 3 times x squared plus 3x plus 9. That's what it means by solving by factoring. Then it wants you to use the quadratic formula. This part, if we set it equal to 0 for the product rule and add 3 to both sides, then we get x equals 3 for a solution. The other part of this equation will not factor, so we're going to have to use the quadratic formula with that. So a is 1, b is 3, c is 9. So the quadratic formula says to do the opposite of b, which is -3, plus or minus the square root of b squared, which is 9, minus 4 times 1 times 9, all over 2 times 1. If you simplify what's under the square root, you will have the square root of -27. And if you'll remember, the square root of -27 is the square root of -1, and then times the square root of 27. But 27 is not prime, it's 3 times 9, which is 3 times 3. So you have to, for every 2, take out 1. So we have 3, this square root of -1 is I, times the square root of 3. So then our final answer would be -3 plus or minus 3i times the square root of 3 all over 2. The other item that we need to discuss is number 71, because you didn't enjoy solving the formulas, that we need to do a little practice on that as well. Okay, it says to solve this formula for t, which means I need to get the t by itself, so the first thing I'm going to do is put the t on the left, because it's always easier for me to solve when the letter I'm looking for is on the left. To undo the 1/2, I need to multiply by 2, because that's the reciprocal. But if we do it to one side, we have to do it to both sides. So then this cancels, because 2 over 2 becomes 1. So we have gt squared equals 2s. Then to get rid of the g, we need to divide both sides by g. So we have t squared equals 2s over g. And then to get t rather than t squared, I need to take the square root of both sides. So t equals, we wrote the square root, so it's plus or minus the square root of 2s over g. On the homework, you need to omit number 78 and 81. Okay, look at number 86, and that's where we actually practice the discriminant problems, which has 8x squared equals negative 14x minus 3. You can't do the discriminant, just like you can't do the quadratic formula, until everything is on the left. So we need to add 14x to both sides and add 3 to both sides. So that means we have 8x squared plus 14x plus 3 equals 0. So A is 8, B is 14, C is 3. So then B squared minus 4AC would be 14 squared minus 4 times 8 times 3. When you put that in your calculator and calculate it, you get 100. 100 is a perfect square because it's 10 times 10. So when it's positive and a perfect square, that means you will have 2 rational roots. You do not have to use the quadratic formula. You do not have to identify the roots. You simply have to identify what type of roots you will have. If you would also look at number 91, 91 has 8x squared minus 72. And it's asking you to do the same thing. Well, A is 8 because it's the coefficient of x squared. B is 0 because there is no x. And C is negative 72. So when you do B squared minus 4AC, that gives you 0 squared minus 4 times 8 times negative 72. When you multiply that, you get 2,304, which you may or may not know is 48 squared. So it's positive and a perfect square, so we have 2 rational roots. All you have to do is calculate B squared minus 4AC, and then go back and look at the table in your notes to determine the type of roots. That should enable you to finish all of the 1.4 homework, multiples of 3 through number 90.